Welcome. In this video I'm going to cover the fundamentals of regular expressions. Regular expressions, or regex, is a pattern matching language used for searching through text-based data, looking for specific data based on character pattern matches. Many tools in Linux support using regular expressions, for example, vim, grep, less, sed, and awk, along with most programming and scripting languages, such as Perl, Python, and Java. One important thing to note is that there is no standard for regex implementation. Consequently, there are variations in the syntax used and functionality supported by each of the languages and tools. The simplest form of regex is the exact match. This is where a series of characters is matched against the search data, and lines with exact matches are returned. For example, if the search criteria was cat, then any instance of that sequence of 3 characters would be matched. Matches are case sensitive, and there can be other characters before or after the search characters. Here are several examples. Dog, a, at, 8, vin, lid, c, on. As you can see, the matches shown so far are an exact match, case sensitive, and can be anywhere in a word or on a line. You can use anchors to help refine where a match should occur. The 2 most common anchors are the line anchors caret and $. These are referred to as meta-characters. If you use the caret meta-character, followed by the search characters, then those characters must be at the beginning of a line. If you use the $. Meta-character at the end of the search characters, then those characters must be at the end of the line. You may have noticed that dog on line 5 was listed in all 3 searches. That's because it is at the beginning of the line and the end of the line. In fact, it is possible to check that a regex match is the only characters on a line by using both the meta-characters around the search characters. It is also possible to look for matches on word boundaries, using \less than for the beginning of a word and greater than for the end of a word. The \ escapes the character immediately following it, the greater than or less than characters in this case. For example, let's search for th at the beginning of a word, at the end. The next thing we will take a look at is wildcards. The primary wildcard character is the period or dot. It can represent any character. For example, c.t will find all instances where there is a string that has a c, followed by any character, followed by a t. Another example might be te dot. The next type of wildcard is the set of acceptable characters for a specific location. The set of acceptable characters are enclosed in square brackets. For example, C open square bracket A O U close square bracket T will find all words that contain the matches CAT, COT, and CUT. You can combine wildcards. C dot open square bracket AOU close square bracket T would match a C character, any other character, followed by either an A or an O or a U, followed by a T. Other examples include C open square bracket 5 capital Q close square bracket T to find the unusual strings, or caret open square bracket lowercase c capital C close square bracket AT to find all uses of the string cat, where it begins the line and the first character could be either a lowercase or uppercase c. Finally, let's take a look at multipliers. The most common multiplier is the asterisk. It applies to the previous character in the expression, usually a wildcard, and indicates that 0 or more of the previous character match. C dot asterisk t in this case, 0 or more characters between C and T. You may notice that the match is done using what is known as a greedy match. That is, match as many characters as possible while satisfying the entire regular expression. Here is another example. C, A, asterisk T, which matches all instances of C followed by 0 or more A's and then a T. Or perhaps this example. C, open square bracket, AOU, close square bracket, asterisk T, which matches all instances of C followed by 0 or more A and O and U characters followed by a T. Another type of multiplier is the explicit multiplier, which uses a number to indicate the exact number of prior characters that should be matched. The number is enclosed in braces, but the braces need to be escaped. For example, C dot backslash open curly brace 2 backslash close curly brace T, which will match C followed by exactly any two characters followed by a T. Another example, C O backslash open curly brace 2 backslash close curly brace T, which will match C followed by two O's and a T. And this example, C open square bracket AOU close square bracket backslash open curly brace 2 backslash close curly brace T, which will match C followed by any two characters consisting of an A or U or O followed by T. Our discussion has only just touched the basic possibilities of regular expression matching. Read the man or info page for the command line tool you plan to use, and locate the coverage of regex for specific syntax and functionality. You could also read man 7 regex. To recap, regular expressions are a powerful and well-supported feature of many command line tools, scripting, and programming languages. Regex is a pattern matching language that looks for matches of the search regex against the input data. The simplest match is a character or string of characters. The caret and dollar are meta characters for anchoring the search to the beginning or the end of a line. And you can use backslash less than and backslash greater than for anchoring beginning or end word boundaries. Period or dot represents any single character, and you can use multiple characters inside square brackets to match any member of that set of possible characters. Multipliers can be used to represent repetition. The asterisk is used to repeat the previous character 0 or more times. Curly braces can be used to specify an explicit repetition value. That completes this video. Thanks for watching.